Okay, this is a first video on the method of undetermined coefficients. And what the method of undetermined coefficients is it provides a way to find a particular solution to the non-homogeneous linear differential equation. So what we can use this for is for finding a particular solution. Particular solution just means finding one solution. Finding a particular solution, let's call it yp, to, let's say, the second order linear differential equation with constant coefficients. Well, we know how to do this when the right-hand side is 0, but what happens if you just have a function of t? And this method will work when f of t involves polynomials, exponentials, and sines and cosines. In this video, we're just going to talk about polynomials. So let's just do an example before getting into any general theory. So suppose that we wanted to find a particular solution to y double prime plus 3y prime plus 2y equals 3t. So what we want is we want some function such that when you calculate the left-hand side, it ends up being 3t. Well, it turns out that so basically we want to guess what a particular solution is going to look like. And so our initial guess for yp is going to be, when you have a polynomial like this on the right, our initial guess should just be a polynomial of that degree. So we have a degree 1 polynomial, our initial guess should be the general degree 1 polynomial. So it's yp equals a1t plus a0, right? A sub 0, these are subscripts. And it turns out that sometimes this initial guess doesn't work and we need to modify it. But for this example, it will work, and let's see why. So what we're looking for is we're looking for a yp, and we guess that it's going to be a linear polynomial. So we need to figure out if it's possible to find a1 and a0 that satisfies, such that your yp satisfies this equation. So suppose it does, okay, then what would have to happen? Well, our yp prime is a1, and our second derivative is 0, right? So the left-hand side, yp double prime plus 3yp prime plus 2yp is going to be 0 plus 3 times y prime, that's a1, plus 2 times yp, which is a1t plus a0. So how does this simplify? Let's gather the terms being multiplied by t. Well, there's 1, there's 2a1, right? And then the constant term is 3a1 plus 2a0. So there's this. And we want this to equal 3t. So that's 3t plus 0, right? So we want this thing to equal that thing. And this needs to be true for all t. So what we can do is we can match the coefficients together and solve. So when we set the coefficients of t equal, we see that we need 2a1 to equal 3. And then for the constant term, it's 3a1 plus 2a0 needs to equal 0. Well, this is a system of equations, and we can solve this system of equations, right? Because the first equation tells us that a1 is 3 over 2. And then when you plug in to the second equation, so this symbol means implies, it implies that 3 times 3 over 2 plus 2 times a0 has to be 0. So that means that you get 9 over 2 plus 2a0 is 0. You take away 9 over 2 from both sides. 2a0 is negative 9 over 2. Divide both sides by 2. You get negative 9 over 4 for a0. So we are able to solve for a1 and a0. And so therefore we get our yp, right? So yp, I'm just going to do it over here. So our yp is 3 over 2t minus 9 over 4. This is a possible solution to the differential equation. In fact, you can check that if you substitute your yp into the differential equation, you end up getting 3t, right? If you substitute to the left, you get 3t. So this is a solution to the differential equation. Okay? So in general, when you have this differential equation, ay double prime plus by prime plus cy equals a polynomial, so where the right-hand side is, say, capital C n t to the n plus capital C n minus 1 t to the n minus 1 plus dot 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 plus capital 1 C1 plus capital C1t plus C0, we should use the initial guess yp equals a degree n polynomial. So a n t to the n plus a n minus 1 t to the n minus 1 plus dot 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 plus a sub 1 t plus a sub 0. Okay, and just to clarify, these are subscripts here. Okay. Now it turns out that this doesn't always work. So it almost always works, but there's a few exceptions. So this usually works. Works meaning that if you use this yp and then plug it into the differential equation, you'll be able to solve for the coefficients. So this usually works, but not when r equals 0 is a root of the polynomial ax squared plus bx plus c. So that means your coefficients here, your a, b, and c, if you form this polynomial ax squared plus bx plus c, which we've done for the homogeneous equation, right? When r is 0 is a root of this polynomial, you have to make some modifications to your initial yp. So we'll take a look at that. So, well, when r is 0 is a solution, that means that c is 0, right? So i.e. and c is 0. Okay, let's see what happens. So, for example, let's say that you had this differential equation, y double prime plus 3y prime equals negative 9t. Okay. So let's try using the degree 1 linear equation again. So you try y sub p equals a1t plus a0. Okay, and then we try the same thing. We figure out what we get on the left, we match it with the thing on the right, and then set the coefficients equal, and then solve. Well, when you do it, so your derivative is a1, and your second derivative is 0. Now when you plug it in, you're going to get 0 plus 3 times y prime, that's a1, equals negative 9t. And now do you see what happens? On the left, you have a constant, right? Your a1 is a constant, but here you have something in terms of t. And this needs to be true no matter what t is. So there's no solution. When you set, if you think about setting the coefficients equal, right, then the coefficient of t on the left is 0, so you need 0 to be negative 9. These are the coefficients of t. So that obviously has no solution, right? 0 can't be negative 9. So you run into an issue in this case. And it turns out that what you need to do when you have this situation is you can modify the initial yp by multiplying by t. So instead of a1t plus a0, the yp that will actually work is going to be t times a1t plus a0. Now when you do that, so this is going to be a1t squared plus a0t. And it turns out that if you do this, if you use this polynomial for yp, the degree 2 polynomial, it will actually let you solve for a1 and a0. So let's try that. So when you take the derivative, you're going to get 2a1t plus a0. When you take the second derivative, you're going to get 2a1. So now you plug it into the differential equation up there. Okay, so it's 2a1 plus 3 times y prime, that's 2a1t plus a0. This has to equal negative 9t. And now let's set the coefficients of t together. So the coefficient of t on the left is going to be 6a1. So you get 6a1 equals negative 9. And then when you set the the constant parts, you get 2a1 plus 3a0 on the left, and you get 0 on the right. And this system we can solve, right? We can solve this. We get that a1 is negative 9 over 6. And that simplifies to negative 3 over 2. And then to find a0, you just plug it into the second equation. So you get 2 times negative 3 over 2 plus 3 times a0 is 0. And that, 3a0 equals 3. Is that right? Yeah. And then a0 is 1. So our yp is going to be, what was it? It was a1t squared. So it's negative 3 over 2 t squared plus 1t. So this is going to be a solution to the differential equation. Okay? So you may have to multiply by your initial yp by t if 0 is a root, if it's a single root. If it's a single root. So here our polynomial, our ax squared plus bx plus c, this was x squared plus 3x, right? And this factors like this, and your x equals 0 is a single root. Now when you have a double root, so if 0 is a double root, well, what that means is if you have a y double prime, so right, because your polynomial, your ax squared plus bx plus c has to have a double root of 0, well, that means it has to be like a times x minus 0 squared, so that's ax squared. So in other words, if you just have ay double prime on the left, then it turns out that you need to multiply your initial yp by t squared. So for instance, if you had like y double prime equals 6t, okay, then well, first it's easy to solve. So I guess you don't really need to do this. But if you wanted to use the method of undetermined coefficients, you would make it be t squared times a1t plus a0. And then you'd be able to solve for a1 and a0. Okay, so we'll talk about more complicated examples with exponentials and sines and cosines later. But this is how you do it for polynomials. Thanks.